In this presentation, we will review the major phases of an issuer EMV migration project. If you have not already done so, you will find it helpful to view the presentations titled Part 4, Issuer Decisions, and Part 5, General Project Management before viewing this presentation. MasterCard, Visa, American Express, and Discover mandated that acquirers and processors in the United States must be able to support EMV data in online transactions as of April 2013. This was an important first step toward the EMV migration in the United States. Once their connection to these payment networks has been certified for EMV, acquirers can begin the process of certifying terminals and rolling them into production. From an issuing perspective, this was also an important step. When you are ready to begin issuing chip cards, networks will be prepared to handle the EMV transactions generated by those cards and EMV-enabled terminals. Issuers will need to make some very basic business decisions right up front. The choices made here will determine the components required for your chip cards and therefore the scope of your project and the cost of the cards. You must allow time in your project schedule to review your options and make decisions that are right for your business. What level of security are you comfortable with? EMV reduces counterfeit card fraud. The addition of a PIN reduces lost and stolen fraud. Will you require your cardholders to use a PIN? You will need to support online authentication, online authorization, and, if your cards require a PIN, online PIN verification. An EMV-enabled point-of-sale device may support offline authentication, offline PIN verification, and offline authorization. Will your cards support offline functions? What type of card interface will you select? Contact EMV only, contactless EMV only, or dual interface? And what level of support will your host system be able to provide? Will your authorization system be able to verify the cryptogram in an online transaction request? Will it generate a response cryptogram? Or will someone else be performing these services on your behalf? What will your chip cards expect to receive in a transaction response? One of the major decisions an issuer faces with EMV is whether to use the same extended bin for their chip cards as they use for their magnetic stripe cards. Your host system or online transaction processing system may not make it easy to differentiate between a magnetic stripe card and a chip card without looking closely at the card data, so it can be helpful to use different bins for your chip cards. If a cardholder reports a problem with their card, your customer service representative will immediately know whether they have a magnetic stripe card or a chip card based just on the card number. This will guide the questions that you ask the customer and your troubleshooting process. This approach also makes it easy to quickly determine how much of your card portfolio has been converted to chip. If you plan to assign pins to your chip cards, how will you provide the customer with their pin? Pin mailer is a common approach. If you do not already know the pin for a card, you will need to assign a new pin to the card. Then, if the cardholder wants to change their PIN, you will need to have a way for them to do that. This is easier if you are not supporting offline PIN verification. If you allow multiple cardholders to share one PAN today, and you differentiate the cards by member number or sequence number, you will probably want to stop this practice when you migrate to EMV. Many EMV functions use the PAN. The chip card will have a transaction counter associated with the PAN, for example. Your host system could make undesirable authorization decisions if multiple cards share a PAN, but the transaction counter shows a different value for each of the cards. A clean approach that many issuers have taken is to assign a new, unique, extended bin for their chip cards. No existing magnetic stripe PAN was used for a chip card. There was a one-to-one correlation between a card, a PAN, and a cardholder. Each cardholder got a new random PIN via PIN mailer separately from their new chip card. All PIN offsets were stored on the host system to facilitate online PIN verification. The PIN offset was not stored in the track data on the chip cards. Decide which card program to start with. Determine whether you will have a smart card management system or whether you will outsource those functions. Look at your current reissuance strategy and see if any changes need to be made for chip cards. How many ICC applications will you have on each card? Will you support instant issuance? If so, will you do this right away or as a separate project later? Be sure to consider the placement of the chip on a contact or dual interface card. You may need to shift information that is displayed on the face of the card so that the chip does not interfere with it. Cards must reflect the issuer's logo, name, and so forth, but must also conform to the design and branding requirements of the payment association. You will most likely have to submit preliminary card designs, color proofs, or even color sample cards to the payment association for their approval. Factor the time and the cost for this step into your project. Every component of a chip card must be certified in one way or another. This diagram shows the different types of certifications that are required before a chip card can be issued in production. Working up from the bottom of the chart, first the hardware and the operating system must be certified by the card vendor. The EMV applications that go on the card must be certified by the relevant payment associations. This is the responsibility of the issuer, but the actual certification can be done by the card provider. Before cards are actually issued, the card personalization must be certified by the payment brand whose applications are on the card. There are many parameters within each application on the chip that guide its decisions and actions based on situations it encounters in the field. Instead of trying to decide how to set all of these bits yourself, it is wise to use a card profile that has already been developed and certified by the card brand. They can provide you with spreadsheets that will point you to appropriate profiles that will ensure your cards will perform as expected based on your business decisions. Using an existing profile will ensure compliance with the card brand requirements and will also ensure global interoperability. Even if you use an existing profile, the proposed settings for each application in the chip must be submitted to the payment association for approval. This certification process is known as Card Personalization Validation, or CPV. Because your cards must be able to generate the cryptogram that will be sent to the host in online transactions, your cards will need the appropriate private keys. If your chip cards are supporting offline functions, that is, offline PIN verification or offline authentication, you must obtain the appropriate public keys and certificates. Contact the payment association for assistance with this step. Gather the cardholder specific data you need to produce each card. This will include the cardholder name, expiration date, and the keys associated with each card. The approved card personalization data, the cardholder specific information for each card, and the approved graphics and card art must be provided to the vendor or personalization bureau in a secure manner that complies with PCI requirements. Don't forget that you will need test cards even before you need production cards, and you will not be able to produce physical test cards for every scenario you want to test. You will need to have simulators that can work with both plastic cards and virtual cards. Even if you are using predefined card profiles, do not be surprised to find errors in your first batch of test cards. Factor time into your schedule for several iterations of cards before you get a set that works exactly the way you want them to. Now you have a real chip card in your hand. But even though the card components have been certified, an issuer still has more certifications to go through. Issuers must undergo functional certifications with various networks. The issuer provides cards to the global payment network, for example MasterCard or Visa, which then acts as the acquirer, sending transactions to the issuer. The network then validates the response from the issuer. After this level of certification, most global payment networks require end-to-end certification. In some cases, the cards are sent to an acquirer. They execute transactions which go through the network to the issuer, and the response goes back to the acquirer. The network in the middle and the acquirer assess the results. Some global payment networks require that the final end-to-end card certification be performed at specific terminals that are known to work according to the global payment network specifications. Issuers may have the option of using a third-party provider to assist with these certifications or even perform these certifications for the issuer. But producing the actual chip cards is just one aspect of an issuer's EMV project. Will your authorization system be able to handle the new EMV data in an online request message? Will you be able to verify and generate cryptograms? Will you be able to generate issuer scripts? You can upgrade your authorization system to perform these functions. You can also find add-on products that will work in conjunction with your authorization system to perform these functions. Or you can have a network or a processor perform EMV functions on your behalf. If you go this route, decide if this is a short-term measure until your system is ready to do this work, or if this is a longer-term solution. If someone else is performing EMV functions on your behalf, will they send you transaction requests with EMV data, or will those requests look just like the current magnetic stripe transactions? Clearly, these are important decisions, and you must know your company's direction in order to create your project schedule. Issuers, networks, and processors will have to look closely at their software to make sure it supports EMV. Today, a network or a processor may offer stand-in or on behalf of services for an issuer. These networks and processors must decide what services they will offer their customers for EMV. Networks and processors who are offering these services must determine how to program and configure their systems for those services. Issuers who are not yet ready for their own authorization systems to perform these services should discuss the available options with networks and processors they connect to. This slide lists some of the on behalf of services that a network or a processor might be able to provide for their customers. Today, they may offer stand-in authorization and PIN verification, and they may still do that. With the introduction of EMV, they may offer additional services. Will they verify and generate cryptograms on behalf of issuers? If so, they will need the appropriate keys. Will they use EMV data in the request message when making an authorization decision? Will they perform EMV functions for an issuer and then send them the request as a magnetic stripe transaction for authorization, receive the magnetic stripe response, and then send the response back to the acquirer as chip? Sometimes this is called message translation. A network or a processor could potentially generate issuer scripts. They would need the appropriate keys and would need to understand the scenarios under which a script would be generated. If your authorization system will be performing all of the functions listed on the previous slide, your development team may have a lot of work to do. Analyze your current online transaction processing software. Make sure it supports EMV. You may need to migrate your software to a later version that supports EMV. Don't forget to look at batch, reporting, back office systems, and other systems. Do you exchange files with upstream or downstream connectors? Do those file formats need to change to include EMV data? Who will you need to test or certify all of your changes with? With so many changes, you can see that QA is probably the most important function of your EMV project. Regression testing is vital. You will also have many combinations of chip and magnetic stripe cards and terminals that you must test. Simulators will fill the gaps with virtual cards, simulated devices, and networks. You must review your internal and external documentation to see what changes may be needed for EMV. Marketing is particularly important for issuers because you have to send the right message to the cardholders about why they are getting chip cards. You will need to explain to cardholders what changes they may see at terminals and how to use their new cards. Emphasize positive aspects such as enhanced security, global interoperability, and the foundation for new products and services. Involve personnel in branches, as well as retailers and your other business partners, and use the media. Devise a plan to transfer knowledge from the project team to those in support roles. Different groups will need different types and levels of training. Once you are coming down to the finish line, you must be sure to notify the appropriate parties of your production dates. Establish clear guidelines for problem reporting, resolution, and escalation, and communicate this information to those who will be the first to receive their chip cards. When you officially begin issuing production chip cards, check to see if the global payment networks offer a limited warranty period. You will want to issue your production chip cards in phases. In Canada, we found that a good approach was to start with the project team. These people know what's going on, how to use the cards, and will be forgiving if there are problems. Plus, you are not exposing problems to the public at this stage. If you do find problems, it may be necessary to go back to the card provider and get a new set of cards. This can take several weeks. If this does happen, you do not want to have to replace a large number of cards. The project team must be sure to use the new cards in as many different types of terminals and in as many locations as possible. Once you are comfortable that these production cards are working as desired, issue a slightly larger group of cards to employees. You might even want to include some family members. Once this is working well, gradually broaden the base of cardholders according to your reissuance plan. Once you have started issuing production chip cards, you will want to closely monitor transaction approval rates and instances of declines and fallback. It is important to react quickly to potential problems and keep in contact with your cardholders. Watch for new patterns of fraud. Do not be surprised to see an increase in card not present fraud. As you can see, issuers have many things to consider, and an issuer EMV project can be complicated. It is impossible to say how long your EMV project will take or how much it will cost until the key business decisions are made and you have done the necessary analysis and planning. So start now and good luck. We hope this presentation has been helpful. Paragon is a leading provider of e-payment simulation, configuration, and testing software solutions. We offer professional services, including EMV training. We have over 590 customers in more than 85 countries. For more information about our products and services, contact us using one of the links shown here.